So in this video, we are going to talk about forces. Let's do a quick revision about what we learned before. Forces are measured in newtons. Its unit is Newton, and it's named after Sir Isaac Newton. Never call him Mr. Isaac Newton, it's Sir Isaac Newton. And he basically defined force. Right? Yep. Now, let's just make it clear. In physics, we measure mass in kilogram. So whenever I go to supermarket, I'm asking for, say, 2 kilogram of chicken wings. I'm asking for a certain amount of mass of chicken wings. Now, force is measured in newtons, similar to weight. Weight is measured in newtons, which is equal to mass times gravity, which is measured in newtons, and the gravity is 9.8 meters per second squared, which is our acceleration. It also can be 9.8 newtons per kilogram. There are 2 units for gravity. It means the same thing. It means acceleration. So somehow mass times acceleration gave me a weight, or mass times acceleration gave me a force. Okay, which is measured in newtons. Okay, now the other component I would like to introduce will be called the normal force. And there are many different types of forces. Weight force is one type of force. Okay, the other type is called the normal force. So let me show you with a diagram what is normal force. So assume I have a block of wood, okay, has m kilogram of mass, okay, sitting on the ground at rest. And what we can say about it is the gravity pull it down to the center of the Earth with an acceleration of 9.8 meters per second squared. Okay? So here is a weight force pulling it to the center of the Earth. Okay? And the weight force can be calculated by mass times acceleration, which is in newtons, mass times gravity in this time. Okay? And newtons, and also preventing this mass from dropping down to the center of the Earth, the ground exert an opposite direction force, and we call that normal force. So the ground pushes it up. Okay. Otherwise, it will fall into the center of the Earth. We don't want to say that. So we label it N for normal force, or sometimes we label it Fn for normal force. Okay. So in this scenario, okay, because of the block is unmoved, is at rest, okay, so the amount of, only in this scenario, okay, it can be different. Okay. In this scenario, the normal force is same as the weight force, which is mj, because it is at rest, it is unmoved vertically. Okay. So this is only in this scenario. If sometimes it will be different, it's not a definition. Okay. The definition for normal force is actually this. normal force is defined as a force acting perpendicular, acting on an object perpendicular to its surface at 90 degrees to its surface. In this case, the surface is the ground, so the normal force is a force acting upwards, okay, which is this in this scenario. So let me show you another example. Now here is another scenario. So we have an object sitting stationary on an inclined surface of 30 degrees. So let me draw the inclined surface first. Okay. So we have an inclined surface of 30 degrees, and we have a block of something sitting there, okay, labeled M. Okay. So when I'm trying to draw the free body diagram on this one, the first thing I have to notice will be there must be a weight force acting directly downwards to the center of the Earth. Okay, so weight force. Now, since it's on a surface, there must be a normal force. Remember, normal force is acting perpendicular to the surface, so it will acting at 90 degrees to the surface. Okay, normal force. So, judging from this, okay, so we have two forces basically pulling on this object. So we have a force goes on this direction here, goes on this direction here. We have another force, the weight force, dragging it down. So the net, if you do your vector calculation, if you add these two forces up, it will be a force pushing it this way. It will be a net force pushing the block this way, so it will force down. However, in this scenario, the object is at rest. Okay, so how does this happen? Okay. Now, in reality, what's happening is there must be a friction force between the surface and the block. There, friction. Okay. So it doesn't force down. Okay. Yep, this is the free body diagram of this object. It is at rest. So, however, let's assume what's happening is we have an inclined angle of 60 degrees. And this time, assume there's no friction. Okay. Let's assume there's no friction. Okay. We will still have a block of mass, and we will have a weight force acting downwards. We will have a normal force acting this way. Okay. Assume there's no friction. What's going to happen is there will be a net force going down this way. Okay. The net force is basically a vector sum of all the other forces. Okay. So in this case, the block would not be at rest because there's no friction. There's no way that that the block can be remained stationary unless we attach a string on it, but that's another story. Okay, so in this video, we learned about normal force, we learned about friction force, and we learned about weight force.